Next comprehension problem is a line PQ parallel to the diagonals PD of a square ABCD with the side length A unit is drawn at a distance x from the vertex A, where x belongs to closed interval 0 to root 2a, cuts the adjacent side at P and Q. Let fx be the area of the segment of a square cut off by PQ with A as one of the vertex. After this one, there are three problems. First is let g of x equals to f inverse x. Then the domain of g of x is. Second is for a equals to 2, the domain of the function phi x equals to root over f inverse x minus fx is slash r. If third problem, if the equation of fx equals to f inverse x has exactly three solutions for all closed interval 0 to root 2a, then the values of a is. Now, according to problem, a square is given ABCD whose side length is A, and a line PQ is parallel to the diagonal BD which distance is x from the vertex A. So this distance is given x. Next is given what? Where x is belongs to closed interval 0 to root 2a. It is intersecting the adjacent side at P and Q. Let fx be the area of the segment of the square cut off by PQ with the A as one of the vertex. So fx is defined as what? Fx is area of triangle APQ. So we have to find out fx. So for finding fx, first we'll take AC length is nothing but what? Root 2 of A. Then AS we can say what? A by root 2. So if I say AR is less than equals to AS, or we can say X is less than equals to A by root 2. Now we have to find out area of triangle APQ. So in the triangle we can say angle RAP is equals to 45 degree because in a square diagonal bisects the angle. Similarly we can say angle RPA is equals to angle SPP, that is 45 degree because these two angles are corresponding angle. So this angle also will come as 45 degree and this angle also will be 45 degree. So we can say triangle APQ is isosceles right angle triangle. So in the triangle ARP, AR is x, so RP also x. So AP will come out root 2x. So we can say AP equals to AQ equals to root 2x. And area of triangle APQ is equals to 1 by 2 into root 2x into root 2x. So what will come? X square. So we can say fx equals to x square where x belongs to what? Closed interval 0 to a by root 2. Next case is what? When AR is greater than equals to AS. That means we can say if x is greater than equals to a by root 2. And fx is nothing but what? Area of this section will be there. So how to find out fx? Fx we can say like area of a square, that is a square minus area of triangle PCQ. So this will be the square area minus this area, we can say remaining area, that is fx. So fx equals to a square minus triangle PCQ area. So we can say CR is nothing but what? Root 2a minus x. So triangle PCQ area is nothing but what? Minus root 2a minus x whole square. That already we did in this triangle. So this distance is x. So area of triangle APQ is nothing but x square. So similarly here also this will be area of triangle PCQ. So how will solve? A square minus this will come 2a square plus x square minus 2 root 2 ax. So if I simplify this one, we'll get what? 2 root 2 a x minus a square minus x square, where x is belongs to what? Closed interval a by root 2 to root 2 a. So this is function fx. Now we can define fx as x square when x belongs to closed interval 0 to a by root 2 and a square minus root 2a minus x whole square when x belongs to closed interval a by root 2 to root 2a. a by root 2 closed interval we can take anywhere. Now first problem is, let g of x equals to f inverse x, then the domain of g of x. Gx is nothing but what? F inverse x. So we have to find out first f inverse x. So fx is given like that. If I take x is greater than equals to 0 and less than equals to a by root 2, then fx is nothing but what? X square, and it is parabola. So this point is 0. So we can say if I take x is greater than 0, then we can say fx equals to x square is increasing function. Then we can say minimum value of fx we will get what? At minimum value of domain. So at 0 we will get what? Minimum value, that is 0. And if I put a by root 2, we will get what? A square by 2. So range of fx is what? 0 to a square by 2. Now to find out f inverse x, what we will do? We will replace x with f inverse x. So what we will get? 0 less than equals to f inverse x less than equals to a by root 2. F of f inverse x equals to what? F inverse x whole square. So from there, f of f inverse x is nothing but x equals to what? F inverse x whole square. So f inverse x is nothing but what? Plus minus root 2 x. Here plus minus root 2x, minus is not valid because f inverse x lie from where? 0 to a by root 2. So we can say f inverse x equals to what? Root x. And if I put here, so what will come? F of f inverse x belongs to closed interval 0 to a square by 2. So we can say x belongs to what will come? Closed interval 0 to a square by 2. So we can say f inverse x equals to root x, where x belongs to closed interval 0 to a square by 2, where range of f inverse x is closed interval 0 to a by root 2. Similarly, if I take x belongs to closed interval a by root 2 to root 2a, fx equals to a square minus root 2a minus x whole square. We can see fx equals to a square minus bracket root 2a minus x whole square is increasing in the interval of what? X belongs to a by root 2 to root 2a. So fx range will come what? Fx belongs to at minimum value at a by root 2 will get minimum. So that will come what? A square by 2. And maximum value you will get what? At root 2a. So if you put root 2a, you will get what? A square. So that is range of fx. Now for finding inverse, so what we'll do? X replace with f inverse x. So what will come? F inverse x will come what? Belongs to a by root 2 to root 2a. Then here what will come? F of f inverse x equals to a square minus root 2a minus f inverse x whole square. So if I simplify, f of f inverse x is x only, a square minus root 2a minus f inverse x whole square. So if I simplify, x minus a square equals to what? Minus of root 2a minus f inverse x whole square. So this will come a square minus x equals to root 2a minus f inverse x whole square. So if I take a square, if I remove, so we can write root 2a minus f inverse x equals to what? Plus minus root 2a square minus x. So if I take minus sign, so it will not satisfy the range of f inverse x. So what we'll take? We'll take plus. So we can write this equation as what? Root 2a minus f inverse x equals to root over a square minus x. So f inverse x equals to what we can write? As root 2a minus root over a square minus x. And similarly, if I put here, so what will come? F of f inverse x equals to what will come? Belongs to a square by 2 to a square. So what will come? X belongs to what will come? A square by 2 to a square. Now we can define f inverse x. F inverse x we got root x when x belongs to what we got? 0 to a square by 2. And we got f inverse x as what? Root 2a minus a square minus x when x belongs to what will be that? X belongs to a square by 2 to a square. So domain of f inverse x is nothing but what? 0 to a square. And this is also domain of g of x. So first problem domain is what? 0 to a square. Question number 2 is, for a equals to 2, the domain of the function phi x equals to root over f inverse x minus fx is R. So instead of a, we'll put 2. So this will put 2, and here also we'll put 2. So what will come fx? X square when x is greater than equals to 0 and less than equals to, if I put 2, so 2 by root 2, what will come? Root 2. And a square is what? 4 minus 2 root 2 minus x whole square when root 2 to x less than equals to a equals to 2. Similarly, f inverse x will come what? Root x when x is greater than equals to 0 and less than equals to a square is what? 4 by 2 is 2, and 2 root 2 minus 4 minus x when x is 4 by 2, 2 less than equals to x less than equals to 4 will come. Now we will find out f inverse x minus fx. So if I see smaller interval is what? 0 to root 2. So if I take x is greater than equals to 0 and less than equals to root 2, f inverse x is nothing but what? Root x, and fx is x square. Next is when x lies between root 2 to 2, and what we can say, if x is root 2 to 2, then f inverse x is again root x, and fx is what? 4 minus this one. So this will come bracket 4 minus 2 root 2 minus x whole square. That is f inverse x minus fx. Now we want to phi x domain, then we can say f inverse x minus fx should be greater than 0 or equals to 0. So root x minus x square should be greater than equals to 0 for x belong to close interval 0 to root 2. So if I see here, if I take x common, root x common, so what will come? 1 minus x power 3 by 2 should be greater than equals to 0. Root x is always positive, and from here what will get? X belongs to close interval 0 to 1. For other function, root x minus 4 minus 2 root 2 minus x whole square, if I check, if I take f inverse x is nothing but what? Root x, and fx is nothing but what? 4 minus 2 root 2 minus x whole square. If I check range of these two functions in the interval of what? X belongs to close interval root 2 to 2. So f inverse x will come as 2 power 1 by 4 to root 2, and fx value will come as, if I put root 2, so what will come? 4 minus 2 root 2 minus root 2 whole square comma some value will come. So if I simplify 4 minus 2 root 2 minus root 2 whole square is what? 2 comma something. So this will come as 2 comma 0. So we can say the minimum value is what? Larger than these two value. Then we can say f inverse x minus fx is what? Less than 0 in the interval of x belongs to root 2 to 2. So from there we can say that phi x domain is nothing but what? Only 0 to 1. This is the answer. Next problem is, if the equation of fx equals to f inverse x has exactly 3 solutions for all x belongs to 0 to root 2a, then the values of a is. We want exactly 3 solution, so that means what? A by root 2 and a square by 2 must be equal. So we can say a by root 2 equals to a square by 2. If I simplify, we will get a equals to root 2. So B is the correct answer. If a equals to root 2, we will get 3 solutions for these two equations. If I take a equals to root 2, so 2 solutions we will get from these two equations. If I equate x square equals to root x, so from there we can say x belongs to 0 and 1, and because a is root 2, so we'll get from here also we'll get one solution. That means we can say there are 3 solutions if a is what? Root 2. So B is correct.